Well, I just recorded this and I forgot to push the talk button, so it's really good if you're deaf, but if you're not, it's not so good. So I'll redo it. I've already got everything written out, so I'll probably go a little faster. So we're going to do problems 1 through 6 first. And problem 1 on page 493. A cube with a volume of, actually I got to go back one more page. So it says a cube with a volume of 64 cubic inches has a surface area of 96 square inches. Is that true? Well, how we handle that is we write down the equation for volume and for area for a cube. Cube has 6 sides that are equal length and equal height. So we know that the volume is 64 cubic inches. 64 cubic inches L cubed. So if we take this and take the cube root of 64, we'll get 4. The way you do that on your calculator, if you don't have the cube root, is you raise it to the 1/3 power. So anytime you have a root, it's always the fractional exponent. So 64 to the, and then you put a parentheses to make sure that the 1/3 was included there, and you get 4. So you might want to check that out and make sure you know how to do something like that. So with the length, knowing the length being 4, then we can plug that into the area formula, and we get 6 times 4 squared, or 6 times 16, which is 96, which is what the problem said. So it's true. Number 2, a tetrahedron has the same number of faces as vertices. Okay, so let's go back and see what a tetrahedron is. So if you look at page 489, you see the 5 kind of regular polyhedron. You see the tetrahedron is the blue one, and it has 4 faces, 4 triangles, and it has 1, 2, 3, 4 vertices. So that is true. Question number 3 says a dodecahedron can be used as a model for a calendar for a given year, where each face of the dodecahedron contains a calendar for a single month, and there are no faces left over. So the question is, does the dodecahedron have 12 faces? So let's go to page 490, and looking in the left-hand column, you'll see those patterns that can be used to do the various polyhedra. And we see the dodecahedron is the purple one. And if you count the number of faces, you see there are 12 faces. So there are 12 months in a year, so that's true. That is a true thing. Okay. Number 4. It says each face of an octahedron is an octagon. Okay, well, let's go look at those pictures again. Same page, 490. We look down at the green, and we see that we have 8 triangles, not 8 octagons. So that is a false statement, because they're triangles, not. Number 5, if you double the length of the edge of a cube, the new cube will have a volume that is twice the volume of the original cube. And that's false. Why is that false? Well, if we took the original length and doubled it, made it 2L, we would be cubing 2L, not L. So when you cube something, you cube each part. So we 2 cubed times L cubed. So this exponent is distributed to each one of those. Well, 2 cubed is 8, not 2. So since it said it would double is 2 times. Actually, it said twice the volume, so it's not twice, it's 8 times. And then the final one is the numerical value of the volume of a sphere is R over 3 times the numerical value of its surface area, where R is the measure of the radius. So this is the equation for the volume of a sphere. This is the equation for the volume of the surface area of a sphere. So I'm going to call X, this ratio between the two, what I would need to multiply the surface area by to get the volume. So if we solve for x by dividing both sides by 4 pi r squared, what happens is the pi's cancel out, the 4's cancel out, 2 of the r's cancel out because r cubed divided by r squared is r. You subtract the exponents, so you have 3 minus 2 is 1. R to the first power is r. So what you'll end up with is r over 3, which is what they said in the statement. So that is true. Okay, now we're going to start skipping them every third problem, starting with number 7. So number 7 is to find the volume of a cube, the volume and surface area of a cube. The volume of a cube is its length times its width times its height. The area is 2 times its length times its width plus its width times its height times its length times its height. So it's all these combinations. L times W, L times H, W times H. And you have 6 faces. So these are individual faces. So we have 3 times 2 is 6, so that's 6 faces. And it doesn't really matter what you call L, W, and H. You get the same answer. So I'm going to call L 2 meters, W 1.5 meters, H 1.25 meters. So now we just plug it in. And mostly this is just an exercise in doing fractions. So length times width times height. Now how do we do that? Well, you've got to convert them to fractions. So 2 stays the same. 1.5 is 3 halves. How do we do that? Well, you've got this is 2 halves plus 1 half. I mean 2 halves plus 1 half is 3 halves. Likewise, this is 4 fourths plus 1 fourth is 5 fourths. You multiply it together, and you can actually do some simplification before you multiply them. You can cancel this 2 here with the 2 that's in the denominator for this fraction. So that ratio becomes 1, and what you have left is 3 times 5 divided by 4, which is 15 fourths. And then we are going to write this back here in the other format. So you divide, you say, how many times can I divide 15 by 4? What's the least number of times? In terms of, I don't want it to be more than 15. So 4 times 4 is 16. So if I had 16, it would be 4. So it's going to be less than that because 15 is less than 16. So you divide, you can see you get 12. 3 times 4 is 12. So that 12 fourths is 3. And then you have 15 minus 12, which is 3. So you get 3 fourths. So 3 and 3 fourths is the same as 15 fourths. So that's your answer. Now to do the area, it gets a little more complicated because we end up with eighths. But the formula is 2 times length times width plus the width times height plus length times the height. So these are the surface areas of each one of the faces, and there are 2 faces. So we get a total of 6. Okay, so what do? We convert these all to ratios of whole numbers. So we already did that. This was 3 halves, this was 3 halves, this was 5 fourths, this was 5 fourths. So we just plug those in there. Then we multiply it out. So 2 times 3 is 6. 2 times 15, 2 times 5, 3 times 5 is 15, 2 times 8 is 8. So you multiply the numerators and the denominators together. Here we have 2 times 5 divided by 4, it's 10 fourths. Okay, now we need to find a common denominator. So you look for a number that you can put in the denominator that can be divided by each one of these terms. Well, 8 can be divided by 8. 8 can be divided by 4 equally, and 8 can be divided by 2 equally. So 8's the number. We don't have to go any higher than 8. So to get 8's here, we have to multiply by 4 in the numerator, 4 in the denominator. Here to get 8, we need 2, so we multiply by 2 over 2. 4 over 4. 2 over 2, which I went ahead and did the calculation. I'm not sure why, but it would melt 2 times 10 is 20, 2 times 4 is 8. Okay, so you multiply that stuff out. You get 24 over 8 plus 15 over 8 plus 20 over 8. Then we add all the numbers, 24 plus 15 plus 20, because they have a common denominator. You get 59 eighths. Again, multiplied by 2. I can't forget the 2. But 2 divided by 8 is the same as 1 divided by 4. You divide this by 2 and you get 1. Divide this by 2, you get 4. So we have 59/4, which we can rewrite as some number and a fraction. And what is that number? Well, 59 cannot be divided equally with 4, so what's the next one up? Well, 60 can be divided by 4. There's 15, so our number is actually going to be a little bit less than 15. It's going to be 14. So if you take 14 and multiply by 4, 14 times 4 is 56. 59 minus 56 is 3, so our final fraction is 14 3/4. Number 10 is a sphere, I think. No, yeah, number 10 is a sphere. It has a radius of 7 meters. The volume of a sphere is 4/3 pi r cubed. The surface area of a sphere is 4 pi r squared from the book. We're going to use pi as 3.14. So all we have to do is just plug them in, calculate them. 4/3 pi, 4/3, 3.14 times r cubed. Our units are meters, so when we cube meters, we'll get meters cubed. So we multiply all this stuff together, we get 1,436, and the units are meters cubed. For the surface area, we have 4 times pi times the radius squared, which is 7. 4 times 3.14 times 7 squared gives us 615. And because we're squaring the units, we get meters squared. So that's the surface area. Number 13 is a right circular cylinder. It has a radius of 5 centimeters, a height of 7 centimeters. So the volume is going to be cubic centimeters. The surface area will be square centimeters. The two equations for volume, pi r squared h. Surface area is 2 pi r h plus 2 pi r squared. The volume you get by taking the area of the circles at the end, the round parts, and then you multiply by the height. And that'll give you volume. Here what we do is we have two parts. We have the circumference of the right circular cylinder times the height. Kind of like the same thing we did here. We took the area times the height. Here we take the circumference times the height. That gives us the surface area of the curved part. And then the ends are two circles. The area of a circle is pi r squared, so you get 2 pi r squared for the two circles. Okay, a little background there. But to get the volume, we just plug in the numbers. Pi r squared h. You get 549.5 centimeters cubed. The surface area is 2 times pi times r times h plus 2 times pi times r squared. Plug all that stuff in, you get 376.8 centimeters squared. Here we got 7 meters cubed. And the final one we're going to do here is this right circular cone. It has a radius of 4 centimeters, height of 6 centimeters. Here are the equations from the book. Volume 1/3 pi r squared h. 1/3 pi r squared h. Multiply all the numbers out, you get 100.48 centimeters cubed. Volume is always units cubed. The surface area, pi r times the square root of r squared plus h squared plus pi r squared. Plug in your calculator, 140.81 centimeters squared. So, don't just write these numbers down. You need to try and make sure you can do it in a calculator. That's probably the biggest place you make mistakes. There's no mercy on calculator errors, so there's no reason for them. So make sure you know what you're doing.